My name is Freddy Lecue. I'm part of Thales, which is a company working on defense, but not only, they're also working on any vehicles that you can think of, planes, trains, aerospatial vehicles. They equip sensors and they provide software and hardware for making them autonomous and making decisions. So I'm a chief AI scientist in this company. It's a French company. I'm based in Milex with the Mila and Facebook and the Element AI and other companies. And I'm leading a team on AI and particularly on eXplainable AI, which is related to the topic that's been discussed by Jules just 2 talks before. And I'll mention, and the goal of my presentation is just to explain or mention or motivate why we need explanation in machine learning AI systems. So that's what I'm going to do for the next 15 minutes. So, well, you all know machine learning get a big buzz and has a huge impact on our life as customers, as end users. So it's all embedded in things that we using on things that we interacting with. So Netflix and Facebook, they all build very nice recommendation systems that they use all of our data collectively, and they build a system that make recommendations. At the end of the day, the applications are great, but are they really changing our life? Well, yes and no. There are pros and cons depending on which applications, and they're working pretty nicely. And the reason why is because of the data that they have. They have huge amount of data, and they can build machine learning classifiers on top and get pretty good results. The thing is, in real life or in industrial settings, the world is not that exactly same context. The reason why is the data that we have in industry usually is not that big. The structure is all over the place. The data is coming from many different sensors, and you have lots of duplicates. You have a lot of contradictory informations, and last but not least, a lot of information is coming from experts. So the experts are sitting down and they analyze the data and they expose more information which is not captured by the sensors and the data, and they try to help those systems making the right decisions. And that makes things very different from what the technology company are doing compared to what usually in industry what you're trying to do. The data is different, and expert is in the loop. The other thing is the decision that some of the industry are working with. They are critical. They have decisive moments when you make a decision. When the system makes a decision, it has an impact on life, on people. It has a huge impact. If you embed a train with some machine learning system that make decisions to speed up or to stop or not, if you make the wrong decision, it just impactful, and that's throwing the government and the regulation companies, regulation firms, and that's where they basically ask more explanations on those systems. So now we're working with a few training companies that want to embed machine learning systems, and the question that they ask and say, we want to get machine learning system, but they need to provide some kind of rational explanation and reason why they're doing so. And certification is a must. If you look at what's going on in Europe, they have the GDPR, which basically protects citizens. And if they make a decision, if they go for a mortgage in a bank, and the banks need to come back with the rationale on why they didn't get that mortgage or that credit. So it's getting more and more current in Europe. And even in here in North America, explanation is crucial for some applications. So, and this explanation part is it's part of a bigger umbrella. It's part of what's called trustable AI. It's basically a system that you can trust. And then if a company is buying that system, they need to have all the certifications and the validity that the system is doing the right job. So there are a few other elements like privacy-preserving AI, which is basically how you build machine learning from data which is basically anonymized, and then you remove most of these signals in the data. So that's the requirement. See, in terms of, so here what you see different quadrants with different kind of applications. And the very first picture I showed at the beginning, which is much more business to consumer, is the one blue when you see the consumer side. When you see face recognition, book recommendation, music recommendations, they are nice to have, but they're not something that would change life of everybody. It will make our life easier for sure. It's a pretty great application, but would they change life and would have an impact on our life? It's debatable. The other one which have huge impact if you make a wrong decision with those systems are the one that you see on the top. Industrial, military is obviously an enterprise. And that's probably where most of the industry today is, but the data that they have, the expertise they have, it's all over the place. It's all coming from many different places, and thank you, and it's difficult for making all system automatic, and they're really starting from a messy place where it's difficult to make things automatic. And that's probably where the AI may have most of the impact if it's done properly. So this slide is a readaptation of what has been presented by the DARPA in the US, where they basically positions most of the machine learning techniques that do supervised and unsupervised learning, and some of those particular algorithms that build models on top of data are much more interpretable than others. So if you look at linear models and decision trees, random forest to some extent, there's something that you can understand by looking at the features, and they just easy to interpret. Others, like neural nets, they're much more difficult to interpret because it's kind of a black box where you have a lot of, first you need to do a lot of fine tuning, and you have a lot of layers and a lot of parameters in there. And they, as you know, they do correlation, they don't do causation. And there's this question on which model, which algorithm you should be using, depending on what you need to do. So it's not because you do have good explanation that you have good accuracy. And sometimes some kind of explanation with only features importance is just enough. Sometimes it's not, because the algorithm that you're using don't really expose that particular features. If you look at the AI field, there is not only obviously machine learning and deep learning, which is one of the subfields of machine learning. You have anything along planning, search, game theory, robotics, knowledge representation and reasoning. And if you look at all of these different fields in AI, they all have different definitions and explanations. They all have done it before to some extent with more funding or less impact, but they all address the problem of I have an AI system, is making a decision, is planning something, is doing some search, is optimizing something, and they want to get the rationale behind. Some are much easier in some cases. So if you look at the KRR field, which is where you do reasoning with logics, it's logic, so it's easier to trace back and get the root cause analysis of a result. So it's much easier to get the explanation because it's a list of axioms that you're using. And depending on the field that we're looking at, they have different approaches. And here is just some example. Obviously in machine learning, dependency plot, feature importance, surrogate models, they have been there for years, and it's been used by most of the data scientists. If you look on the right, on the computer visions, saliency maps is the way to go if you want to explain an object detection, for instance, task. So to have many different approaches depending on what you want to do, and that's all depending on what is the model that you're building. And again, on the explanation side, depending on what you want to do. So Jules presented LIME, where they present explanation, but then how you evaluate that explanation. We had a comment that say, well, they do random patching, and then how you do the reproducibility of the experimentation. Well, that's a tough question, and that's the right question to ask, because you may end up with different explanation with the same data in different contexts. So then how you evaluate, is it comprehensible, the explanation succinct? Can you action the explanations? Is it something you can reuse? Is it accurate or complete? There are a lot of things that that the community in explainable AI try to solve, but usually they reduce this problem in terms of size of the succinctness of the explanation. So that's a slide to mention that Thales is part of a bigger consortium where we have other industrials and academic partners to address this problem of explanation and robustness in machine learning. So how we build systems which are robust and to bias data, which scale, to change to attacks, they provide certification. So when you get the machine learning system embedded in a train, make sure that it's certified and is doing what it's supposed to do. And if you're only looking at silencing maps, they provide nice visualization on where the decision has been made based on which features, but they won't give to the operators the right information to believe or to trust on the system. And there are also explicability, interoperability, and privacy by design. And to conclude, so there are mainly two kind of machine learning wave. They are the machine learning wave from what we all see on news, based on large amount of data, which is the data that we have, that we share with those different companies, and they build brilliant services for us, and it's driven by the big data, and that's the requirements. They need to get that data and that signals to build those patterns, and it's mainly technology companies that are in those, and they provide fantastic results. And if you look at the other way, which is much more the industrialized AI, the data is not that big, even if it's coming from sensors. They all disconnected. They have been deployed. Those sensors have been deployed with no reasons to be. Right? So they have been there for collecting some data locally, but then you end up with a mess of sensors, and how you make sense out of it. That's where you need experts that help you understanding some of the information which is not in the data, and that expertise is crucial. So then how you combine these experts with this data that we have, and then how you make them the decision made at the right adoption in the industry. And what you see, the Gantt chart, the chart that you see where deep learning is and where it should be, and when you will have mass adoption. So now a lot of applications, and on applying machine learning, or a lot of people say, I did that using this particular techniques, let's now try machine learning. We have a lot of people enthusiastic about this, and now they try to make it much more industrialized, but that's not where we are. There's a lot of funding for trying things out, but it's things that people are trying. So mass adoption is one of the key driver for measuring the impact of machine learning and AI. And last but not least, so as I mentioned, I'm part of CortAIx, which is the Center for Research in AI in Thales. We're based in Milex. We're recruiting, so we're working on explainable AI related topics. So the slide which presented how we do explanation in machine learning, in representation and reasoning, it's kind of the work we're addressing. We're working towards the Mars mission. So, and there's a lot of questions on applying machine learning in those particular contexts. We're working with with airports and airline companies for making their flights safer, and that's an issue in some companies. So so that's basically it. So if you want to discuss any of the openings we have, so it was light, so no technical content. It's just much more an overview of the work we're doing and where we're going after. And yeah, so that's it. That's conclude what I wanted to say.
Time for questions. Is there any interest for natural language generation for explanation in AI systems?
Yeah, it's a good question. So, at the end, you provide an explanation either for machines to take actions and to reinforce or to make action on top, or for the human to understand what's the explanation. And if you end up with a set of features, it's good. It's a first start, but usually you need to combine a glue between those and how you communicate. And if I provide an explanation to a person, it might be different from you or to another person. And then how you personalize that and how you communicate and how you do a conversation with the person, it's something that it's in our roadmap on how you make it not a one-shot explanation for everybody, but a personal explanation which is much more interactive. So there's a conversational element to it.
Like a chatbot?
I'm not sure. It's not like the term I like. Chatbot. It's been oversold, I think. But some kind of, because chatbot you can think about everything is hard coded, but something like conversational like, but not a chatbot like. It's much more research.
Any other problem distribution?
Thank you for your talk. Basically, the concept of AI expressibility and comprehensiveness has been since, I guess, 1985. And it has its era and it goes down. And now I see like many people are talking about like more explanation of the AI. What do you see the future of like working on such a project, AI explanation, and what's the role of knowledge and logic and reasoning in this special field?
Yeah, well, yeah, agreed. It's a term that emerged again now, but it's a 1980 topic. Explanation was not new. If you look at eXplainable in AI, it has been rebranded, so it's definitely not new. The thing is now it's getting current. So now industry care, and for what I'm seeing in the industry I am, and I've been working in IBM and in Accenture, I've been people questioning, why shall I trust the system? If I get the system doing this job, and if we fail lamentably on a particular thing, I don't want that to happen. So they need to be sure that it's going to work, and they need to get that experience. So, and a lot of people will say, I just won't deploy it. We discuss with some railway companies, and they say, we have something which is based on rules, working pretty nicely. And we want to try deep learning based on our computer vision data and all the picture that they have. But they say if that fails, it's critical for our business. So we can't go in that particular market. We just go and just wait for what's going on. And a lot of those companies think the same. So if we really want machine learning at scale, that's something you need for some industry to guarantee. Some will say, well, if you get 100% accuracy all the time, that's fine. But you always have one case. If you recommend a movie, if that one case is wrong, well, who bother, right? You lost 2 hours of your life. But it's even a train, full speed, that's a different story. So, and where it's going, I don't know. The eXplainable in AI, it's well, as you say, it's not new, but now there are much more and more people working on that topic on different versions, and they try different things, much more on computer visions, much more on knowledge representation. So the where it's going, hopefully they will get any model, and we provide an explanation that a human can interpret and can understand. And now we're not at the stage that it's easy for human. Every time I show explanation from Lime or from Shapley values, if you know from game theory, people would say it doesn't say much, right? So they need more things glued to the human and to the expertise. So yeah.
I was suggesting that one of the main challenges, or one of the future challenges of AI, is compromising between the robustness of, for example, algorithms based on neural networks, and transparency we can find, for example, with set coupling, say, for example. And what would be the implications, in your opinion, for artificial general intelligence? What challenges does the reconciliation of these two directions have for the ultimate evolution of an AGI?
Yeah, I think this is when you discuss with experts in the field or even non-experts, they all tell you that it's now in the AI, it's not really AI, and the real AI is AGI actually, which is far ahead. We're very far from there. And if you look at what's going on in the US, they started a new mission on what will be the new AI, and you definitely have the mix of how you it's one pillar among others, but it's about transparency of those models and how you make the machine learning and the representation and reasoning side together, and that's something that they want to go after. If you look at some of the work that the Mila is doing, it's also about integrating knowledge representation to be more generalizable. So you learn a model or systems based on some data. It's working nicely in a particular setup, and how you do scale to much more difficult, much more complex domains, and that's exactly where some people are going, and that's where funding will be. If it's the only one challenge, no, that there are many other challenges, but robustness for adoption in industry, it's one of the most. It's not for all, but for some application.
And how do you deal with bias propagation and explaining bias, basically? So, we know that there are some issues now with bias in predictive models, and if you accept that bias and if they're completely explainable, but they're not right, and ethically they're not right, and we're just propagating this in the system. So how does your model address this, or how does this address? How does your work address the bias?
It's a good question, and it's an open question in the AI community. So they try to address this problem of bias, and the explanation. If you build the explanation system, they should be able to light up on some bias of your data. So if you explain a few predictions and you say that it's obviously biased, then you should say it from the prediction you get. So then on how you use those explanations to reshape the data in the right way. And there's this topic in AI about fairness and bias. So it's very connected together. So if you build the explanation, it should highlight where the bias is. You should adapt the data accordingly and rebuild the explanation. It's kind of a loop system where both are considered.